Recycling sounds simple until you actually try to do it. Every city has different rules, and a lot of everyday items are surprisingly hard to figure out. Is this plastic recyclable? What about this greasy pizza box? Rules vary and packaging labels are inconsistent. Recycling should be simple. That's what sparked the idea for Eco, a mobile app that helps take the guesswork out of recycling one scan at a time. Overview of our prototype. Our prototype for Eco was designed through Figma. Eco is a conceptual app that allows users to take a picture of any item and receive feedback on whether it's recyclable or not, by using a combination of visual recognition and region-specific recycling data. The app also includes Eco tips, personal sustainability stats, and a reward system that gives users points for every scan they complete. We wanted to make environmental impact feel personal and accessible. Feature walkthrough. We wanted Eco to not just look good, but fit seamlessly into users' daily routines. Let's walk through how someone might actually use it in real life. Let's say you just finished your boba. You're standing by the trash and you're not sure what to do with the plastic cup, the film seal, or the straw. You open Eco, snap a picture, and it gives you immediate feedback. It's clear, local, and it helps you make a better choice in the moment. Later, you check your impact. Eco shows how many items you scanned, how much waste you've diverted, and your estimate CO2 savings. It turns small actions, like recycling a boba cup, into visible progress. You even earn points with every scan. Over time, you can redeem them for gift cards or sustainable products. It adds a fun layer of motivation to everyday choices. Because Eco knows your zip code, the feedback is always relevant. What's recyclable in the LA might not be in a different city. Eco adjusts for that automatically. What aspects of the design we chose to prototype and why? We chose to prototype two core aspects of Eco, the scan-to-feedback process and the location-based recycling logic. These were essential to explore because they directly relate to the role of the app, helping users make fast, confident recycling decisions. We also focused on look and feel, creating a clear, motivating interface that reinforces user action with personalized stats and rewards. But just as importantly, we began exploring implementation. Even without a working backend, we simulated how scanning might work by designing flows that mirror how visual recognition tools like Google Vision or Apple Core ML could identify items, and how region-specific rules could be pulled in based on a user's zip code. For example, in our prototype, when a user scans a finished boba cup, Eco simulates recognizing the material and checking it against the user's local guidelines. This lets us test technical feasibility, uncover usability issues, and evaluate how well the app could integrate into someone's real-world behavior. Importance of prototyping this now. Prototyping this now allows us to identify potential usability issues early, like whether users understand the scan results or how we display stats. It also gives us a chance to validate our assumptions about user motivation, like whether rewards actually encourage more sustainable behavior. Technical skills, tools, and barriers. We used Figma to build our prototype, learning how to design interactive user flows and simulate app functionality. We researched potential image recognition tools such as Google Vision or Apple Core ML to power the scan feature. We also explored how we might integrate with local recycling databases for region-specific feedback. One of the biggest barriers was figuring out how to simulate back-end logic without a functioning database or camera system, so we designed around that with realistic use cases and placeholder flows. Testing and evaluation. To evaluate the success of our Eco prototype, we based it on usability, clarity, and user engagement. Specifically, we're looking for signs that users can easily navigate the app and understand how to scan an item. They interpret the results and trust the region-based recycling guidance. The stats and rewards features motivate them to continue scanning and learning. To gather feedback, we use surveys through Google Form and semi-structured interviews. Feedback showed that users appreciate the clarity and user feedback of the app. However, some brought up the issue of the interior of an item. For example, Eco might classify the exterior as recyclable, however, it may not recognize the interior, which may not be. We also learned that the reward system incentivizes people to stay engaged. After receiving feedback about Eco's ability to detect internal components, we looked into the capabilities and limitations of current image recognition tools. Through this research, we found that these systems often struggle with identifying non-visible elements. However, several apps that rely on computer vision use follow-up prompts to improve classification accuracy when AI confidence is low. Inspired by this, we designed a follow-up question system in Eco that activates when an item could contain hidden components. This allows users to confirm or clarify what the app can't see, improving the app's accuracy without requiring advanced or unavailable technology.